Welcome everyone. I am B. Lavanya, Assistant Professor EC Department. Today I am going to discuss microstrip antennas. The basic geometry of a microstrip antenna consists of a metallic patch printed on a grounded substrate. The three commonly used feeding methods are coaxial feed, strip line feed, and aperture coupled feed. The patch antenna's idea was first proposed in the early 1915s. The microstrip patch antenna offers the advantage of low profile conformability to a shaped surface, ease of fabrication, and compatibility with integrated circuit technology. But the basic geometry suffers from narrow bandwidth. In the last 3 decades, extensive studies have been devoted to improve the performance of this antenna, and the microstrip patch antenna has found numerous applications in both the military and commercial sectors. Patch antennas are manufactured in different shapes. The geometrical shapes consisting of a square, circle, rectangular, ellipse. These are all the geometrical shapes of different types of patch antennas. The most commonly used patch antenna is the rectangular patch antenna. The shape of the patch is like a rectangle, which is printed on the dielectric substrate. And the width and length of the patch antenna is of the order of microwave wavelength. Here we have three different substrate. One is the substrate, ground plane, and the patch antenna. The most commonly used feed technique is the coaxial feed technique. The advantages of microstrip antenna or patch antenna, which is also known as printed antenna, are given as follows. Lightweight, low volume, low profile, planar configuration, which can be made conformable. Low fabrication cost and ease of mass production because of the easy of design. Linear and circular polarizations are also possible for these microstrip antennas. Dual frequency antennas can also be realized. Feed lines and matching network can be easily integrated with the antenna structure. Coming to the disadvantages, it has narrow bandwidth, that is from 1 to 5%, low power handling capacity, practical limitation on gain, that is around 30 dB, poor isolation between the feed and the radiating elements, excitation of surface waves. Tolerance problems requires good quality substrate which are expensive. Polarization purity is difficult to achieve. Size is large at lower frequencies. As it is based on the wavelength, the size of the patch is entirely dependent on the wavelength. For low frequencies, the size will be very large. Coming to the applications, the microstrip antennas have found so many applications such as phasers and mobile phones, Doppler and other radars, satellite communications, radio altimeter, command guidance and telemetry in missiles, feed elements in complex antennas, satellite navigation receiver and biomedical radiator. Various microstrip antenna shapes has annular ring, square ring, triangular, and semicircular also. Coming to the feeding techniques. The most commonly used feed technique is the coaxial feed technique. The coaxial cable is inserted into the patch by drilling a hole into the patch antenna, and we can place the feed at any convenient desired location based on the impedance matching requirement. The height of the substrate here is denoted as h, and the dielectric constant of the substrate is given by epsilon r. The length and width of the patch antenna are again based on the wavelength of the frequencies of operation. The hole should be drilled where we have to keep the coaxial cable. The outer conductor of the coaxial cable is attached to the ground plane and the inner conductor is attached to the patch. It is easy to fabricate, but it has the disadvantage such as narrow bandwidth. And it is very difficult to place the feed position once it is fixed. We have to again drill the hole into the patch, which makes the design complicated. Coming to the next, microstrip line feed. It is the simple and easiest feeding technique which has the same microstrip line as the feed which is used for patch. So the width of the strip line is very narrow compared to the width of the microstrip patch. So it is conformable to the surface, so less radiations are there. And coming to the length of the strip line, it is of the order of wavelength. It is placed such as it should be matched to the impedance of the patch antenna. It is of low cost. Here there are different types of microstrip line feed techniques. The first one is non-radiating edge, and second one is radiating edge with inset feed and radiating edge with quarter wave transformer. Here in the inset feed, the length of the strip line is inserted into the patch and it is used for impedance matching purpose. And coming to the quarter wave transformer, the quarter wave line is used for impedance matching purpose, which is again connected to the strip line and to the patch. Electromagnetically coupled feeding techniques. Here, this is a non-contact feed method of microstrip antennas, where we have radiating patch at the top of the substrate and we have the feed line at the ground plane. So it is a non-contact method and it is effectively used for various applications. Coming to the aperture coupled feed. Aperture coupled feed requires two different types of dielectric substrates, one with high dielectric constant and another with low dielectric constant. Both are sandwiched. Both these dielectric substrates are placed above the ground plane and below the ground plane. So here the ground plane is sandwiched between these two substrates. First one is the radiating patch and next one is feed line is connected in first dielectric substrate and then the patch is connected to the second dielectric substrate. There is a small gap provided in the ground plane such that there should be a coupling between the dielectric substrate 1 and dielectric substrate 2. It is also a non-contact method, but by using this method, the height or thickness of the substrate is increasing, which in turn reduces the bandwidth. And there should be fabrication of multiple layers, which makes the design complex. It is the comparison table for different types of feeding techniques. Coming to the spurious feed radiation, which is more in microstrip line, and it is also more in coaxial feeding technique. In non-contact feed methods such as aperture coupled feed and proximity coupled feed, there is a minimum amount of spurious feed radiation. The reliability is better in microstrip line and it is poor due to the soldering in coaxial cable feeding technique. Aperture coupled feed is good and proximity coupled feed is also good in reliability. Ease of fabrication. The easiest fabricating method and simplest fabricating method we have is microstrip line feed. Next one is coaxial feed soldering and drilling is needed. Aperture coupled feed requires alignment and proximity coupled feed also requires alignment as these two are the non-contact methods of feeding techniques. Coming to the impedance matching, the impedance matching is easy in all the four feeding techniques. Bandwidth is 21% in aperture coupled feed and it is 13% in proximity coupled feed. But in coaxial and microstrip line feed, both these are same. Coming to the design of microstrip antenna, first we need to know the resonance frequency at which we want to design a microstrip antenna. So here we have to find the length and width of the patch antenna and where should be the feed must be located. LE is equal to L plus 2 into delta L. Delta L is the length that is increased due to the fringing effect. WE is equal to W plus 2 into delta W. That is also due to the fringing effect of the rectangular microstrip antenna. Delta L is given by h by root epsilon E. F naught is equal to C by 2 root epsilon E into M by L whole square plus N by W whole square whole power 1 by 2, where M and N are orthogonal modes of excitations. Fundamental mode is TM10 mode, where M is equal to 1 and N is equal to 0. These are the modes exciting in a rectangular microstrip antenna: E-field distribution, voltage and current variation, and the two radiating slots and equivalent transmission line model. The radio frequencies which are applied to the microstrip antenna will propagate through the edges of the patch antenna, and the E-field directions are correspondingly like this. In the first figure, we can see the field variation in the dielectric substrate. The height of the arrow indicates the magnitude. The direction of the arrow indicates the value, whether it is positive or negative. Here we can observe the fringing effect. That is, here we can have so many lines of E fields that are bulged at the ends. That is due to the fringing effect. The fields at the edges. The microstrip antenna radiates from the edges. Here it is shown clearly in figure C. We can see delta L here and another delta L here. So this is the increase in the length due to the fringing effect. These two are the radiating slots compared to the non-radiating slots along the length of the rectangular patch antenna. The voltage and current distributions at these two ends are denoted in the figure. This is the equivalent transmission line circuit diagram of the patch antenna. Coming to the design equations, the effective dielectric constant is given by epsilon r plus 1 by 2 plus epsilon r minus 1 by 2 into 1 plus 10h by W whole power minus 1 by 2. And W is the width of the rectangular patch antenna, which is equal to C by 2 F naught root epsilon r plus 1 by 2. Smaller or larger W can be taken than W obtained from this expression. So the bandwidth is directly proportional to W and gain is directly proportional to W. The effective length, which is increased due to the fringing effect of the patch antenna, is given by LE is equal to L plus 2 delta L, which is equal to lambda naught by 2 root epsilon E, which is equal to C by 2 F naught root epsilon E. We have to choose the feed point X in between L by 6 and L by 4. We can use these design equations in designing any antenna whose frequency is known and whose dielectric substrate is also already known. So by knowing the dielectric substrate, we can know the value of dielectric constant, and according to that, we can apply all those values in these equations in order to obtain the effective length and width of the rectangular patch antenna. So from these equations, we can find length and width of the patch antenna, and the feed point that must be chosen, that must be between L by 6 to L by 4. So by taking one example, we can explain what is the design of rectangular microstrip antenna for Wi-Fi applications. We know the Wi-Fi range is from 2.4 to 2.483 gigahertz. We have to choose the substrate whose value is 2.32, or we can choose any other substrate also. The height of the dielectric substrate is given in 0.16 centimeters, or in millimeters we can take. And tan delta is the loss tangent whose value is given by 0.001. So by applying the equations we have mentioned previously, we can find the width of the rectangular patch antenna, that is given by C by 2 F naught root epsilon r plus 1 by 2, which is equal to 4.77 centimeters. And epsilon E is given by the formula epsilon R plus 1 by 2 plus epsilon R minus 1 by 2 into 1 plus 10H by W whole power minus 1 by 2, which is equal to 2.23. The effective dielectric constant is approximated to the actual dielectric constant. We can observe the value of epsilon R given here is 2.32, whereas the effective dielectric constant is given as 2.23. The difference is very small compared to the actual value. So the effective length is given by LE is equal to C by 2 F naught root epsilon E, which is equal to 3 into 10 power 10 into 2 into 2.44 into 10 power 9 into root epsilon E value is given by 2.23. So we are getting the effective length value as 4.11 centimeters. Coming to the normal L value, which is obtained by the equation L is equal to LE minus 2 into delta L. Delta L is also found by using the previous explained equations. From these equations, we can find the L value LE minus 2 delta L 4.11 minus 2 into 0.6 by root 2.23, which will give you 3.9 centimeters. So the effective values of the length and width here we obtained are 4.11 centimeters and 4.7 centimeters. So it is the design example for rectangular microstrip antenna. Thank you. Thank you.